So, hello, everybody. Welcome to Monroe Live Podcast. I'm Al Steyer, Vice President of Technology and Research here at Monroe and Associates. Got a very diverse background. I grew up in upstate New York, working on dairy farms where I learned to drive tractors, learned to weld, and things of that nature. From there, I realized dairy life wasn't the life I wanted, so I ended up in the military. I was in the U.S. Army for 12 years. I was a Bradley fighting vehicle mechanic, so I learned a lot about electrical drive systems and things of that nature. After the Army, I ended up at RWD Technologies, developing, delivering training for new product for Chrysler for about 5, 6 years. And then I end up here at Monroe. I've worked on a little bit of everything: hearing aids, fighter jets, nuclear reactors. And with that, today I'd like to introduce Mark Schwager. He's the president and co founder of Monarch. He brings about 15 years of experience leading manufacturing organizations, during which he developed an astounding 16 million square feet manufacturing space. His impressive career includes pivotal roles at Tesla, where he worked on the Gigafactory. He also worked in collaboration with Toyota on the RAV4. And then at different points, there was another company he worked for. I think it was Zoop or something like that, if I'm not mistaken. It sounds like you've had a pretty exciting journey so far, and looking forward to hearing some of the insights from you. So, welcome to the show, Mark.
Well, thanks a lot for the introduction, and thanks again for having me on the show.
So, before we dive into the Monarch, I guess, when we see Tesla, it always catches our eye. I've run into a lot of people that worked at Tesla in the past and they moved to different facilities. But it sounded like you were working in the Gigafactory project from its early concept through the construction. Could you share some of the insights and the challenges you faced when you're pulling that off?
Certainly, and that was one of the most fun things I think I've done in my career is basically building the first big battery factory in the United States with Tesla. I think one of the things that was really interesting about that project, along with the site selection, which I think it was pretty public how Elon was sort of going from state to state to try to win the biggest incentive package. And Nevada was chosen partly because of that, but partly because of the speed by which we could execute the project. So that was really really fun to see him operate in that sort of public way to get the best deal for Tesla. And then in terms of designing and building the factory, that was really much more my role. Um, One of the most interesting things was spending probably about 9 months traveling around the world to figure out where every single material in the cell comes from, just to understand what does it make sense for us to do at this facility, how far up the chain do we want to vertically integrate, and then what's practical to do. Where it ended up and where we thought it was going to end up ended up being two very different things. But learning the maximum extent of what we could vertically integrate on a single site, basically with no holds barred, was probably one of the most fun experiences. And then whittling that down into something practical, I think was the big challenging part. And then doing it at hyperspeed, of course.
Oh, everything's hyperspeed these days. So when you say it was a gigafactory, was that the battery factory?
Yeah, it's the battery factory in Nevada that Tesla operates today.
So was that just the cell manufacturing, or were you building the packs there as well?
It was intended to be cell all the way through pack, and then Tesla did some other things there past my time.
Hmm. Yeah, I know. I've been doing a little bit of traveling lately, and Ford's putting up a big plant down in Kentucky, down by Bowling Green, and that place is just massive. And on my way home, I get to drive by what used to be the Palace. It's where the Pistons used to play. Now it's basically it's a dirt lot, but they just started putting structure up, and I think GM's putting a battery plant in there, so it's got a lot of space there for that it's going to be occupying. All right, so then from there, you moved on to Zoox, autonomous car, autonomous transport system. Maybe that's a better way of saying it.
Yeah, certainly an on-road transport system. I wouldn't exactly call it a car because the way that the founder always pitched that company was it's not the car, it's what comes after the car. And essentially, it was the first on-road worthy vehicle with carriage seating, so you can sit facing each other in the vehicle. No seat, no steering wheel. And really, it was one of the technology leaders in the space in terms of being able to drive safely, autonomously, high speed, long distance. And really, it was a completely an ecosystem play. So it wasn't just the car, it was the service, the network, the technology, really the whole thing, an absolute Silicon Valley moonshot.
Mm. So, what was your involvement in the project?
So in the very early part, it was, and I was only there for about a year. It was essentially figuring out how do we build these first vehicles, who do we want to partner with, both for the design, the engineering, the manufacturing side, bringing all of those parties together, and then executing to a very very tight project plan to bring about the first vehicles. And we were successful at doing that.
All right. Well, so I guess that's a little of your background. So I guess the real reason we want to talk today is, can you tell us a journey that led you to the creation of the world's first fully electric driver optional tractor?
Yeah, so for me, it's very much from a manufacturing lens. And the first time my co-founder started talking to me about this idea, I think it was 2017, and I looked at the farming space, and I'm not a farmer. Nobody in my family is a farmer. Never driven a tractor. You know, what is this thing? And I looked at the farming space and looked around for electrified vehicles. There was nothing. There's no electrified vehicles in farming in 2017. Then I really looked at it from a manufacturing lens to say, what is a farm anyway? Um, and to me, I don't see, a farm. I see a food factory. And the equipment moves, but essentially you've got manufacturing process equipment. The process is the seasons of the year and what happens to the crop, and then what's done to the crop. And so what I didn't see was really manufacturing discipline, manufacturing technology, or a manufacturing approach to farming. Also, you have a big difference where in manufacturing you have sort of 90% control and 10% variability. You sort of have the opposite in farming where it's highly variable, very, very little control unless it's really indoor farming. But indoor farming is just too small to be able to really solve any food challenge. So what I saw there was a great opportunity to bring all that I've learned from the manufacturing sector and then apply it somewhere else. And then combined with electrification was a really easy sell for me to say, this is a problem that I really want to go after.
Okay. Yeah. When you talked about the manufacturing side of it, do you know where how Henry Ford came about the first assembly line?
I don't know. You sound like you have a lot of Ford history up in there. So
No, not a lot, but it's just one that, we do what's called a hearts and minds when we do workshops, and that's one of the things we discuss. But actually, he got the idea when he visited a slaughterhouse, you know, except, at the time, cutting up the meat, making steaks and all that. He must have walked through it backwards and saw a cow at the end. And it's like, hey, we could do this. Um, so just thinking about that, how does Monarch Tractor's technology stand out from others in the agricultural area?
Well, I think very similar to the things that I've been in the past, whether it's Tesla or Zoox, it's really from the ground up a completely different type of vehicle, or where a lot of the OEMs in the automotive space, at least back in 2010 when I started at Tesla, or the OEMs that we see in agriculture today, when they approach electrification, they approach it from, how do we stuff the battery in here? And how do we try to put some automation on this existing vehicle? So how do we not throw away everything that we started? And I've seen OEMs take that route pretty much with every single industry. So agriculture is no different. And really, we've taken why don't we start with the guts of the tractor and what it needs to do for the customer, and then work our way out. So start with the battery, design around the battery, design around a swappable battery, design around a fully by-wire architecture for not automating navigation for the tractor, but automating operations. And then you have to really think about the guts of this thing and how it needs to be able to operate in terms of the hydraulic systems, managing implements, things like that, rather than just can it drive in a straight line.
Yeah. Um, yeah, that just I had a bunch of questions all along those lines. So, when you said design it around the battery, so is there I mean, you designed the battery, I take it?
Our team designed the battery pack, and we did not design. Many automotive companies go all the way down to the cell level. We buy modules.
Okay. When you say a module, you're talking from a supplier that supplies a module already, like a 48 volt or
Yeah, it ends up being our system voltage is up around 400, but the module itself, I believe, is around 16 volts.
okay. So you just connect a bunch of them in series until you get to the 400 volts. So you have really no design control over the module itself.
That's correct. We use an off the shelf one, and that actually gives us a lot of interoperability between suppliers. And we've been able to find this standard module that we buy in many different places.
You're probably not going to tell me who it is, are you?
I'm not allowed to.
Okay. It's always challenging. I'm working with, I've worked with a number of startups. I've done tractors, we've done mining equipment. I'm doing a street sweeper. And, pretty much everybody's like, okay, yep, I'm getting this module from supplier A, B, C. And then they're just trying to pull it all together after the fact. Um, so, what were some of the key challenges you face in developing this electric tractor?
Um, what didn't we have? I would say, we embarked on a very rapid development process. So basically, we iterated the tractor every single year. The betas, and we built two of them. The first thing that we learned was what many learn in electrification is that the battery is too small. And we couldn't get the runtime based on the operations that we really wanted out of the tractor to be able to hit a full day. So basically, we doubled the size of the battery from the betas to our pilot series. A number of other things that we learned is that we had no production pathways, and from a cost standpoint, in many of the choices that we made on the betas, we had some blind spots in our perception stack, and quite a bit of inefficiency in the distribution of power across the entire systems. So then we went to our pilot series. We had a lot of production pathways, a lot of components that we thought were going to carry forward. A lot of Silicon Valleys might have gone to production with that one, but we knew it needed one more. We had some durability issues. We had some efficiency issues. This was kind of COVID, so there were a number of supply chain snags that we had at that time, even in making 20 vehicles. So we kind of weaved our way around those when it came to making production decisions. A number of technical challenges, consistency, and still cost was a major issue. So we really went through this process of learning from iteration to iteration before we hit production.
Yeah, there's a lot of things I want to talk about. You said you're purchasing, when you get into the motors, I'm not sure on your battery packs, but a lot of these guys are seeing like 6 to 8 month, lead times before they can get it. They're like, "Oh, we want to be in production next month." I'm like, "Well, you better find a motor because they're not available." So, when you talked about accelerated, path to production, that's definitely a big one there. When you were talking about the battery, I guess the one question I have, how many kilowatt hours is the pack itself?
It's right around 110.
Okay. Yeah, so it's kind of like the Ford Lightning. I want to say is around 140. Teslas are in the 80, so that's a pretty good size pack you got there. And then what are some of the other things? How do you see Monarch Technologies helping farmers reduce their carbon footprint? I think that's pretty obvious, but
Well, it's obvious with respect to the tailpipe and not having a diesel fueled tractor. What it can really allow us to do, though, is through the automation. Essentially create the economic pathways to try different and or more sustainable practices in farming. So if, for example, from a weeding standpoint, if it's possible to be done mechanically rather than chemically, farmers being stewards of the land would much rather do that, but the economics prevent them from doing so. If we give them the right platform that allows them to do that, then it will unlock the economics for a fully mechanical weeding process, thereby eliminating chemicals in the runoff systems, for example. So there are all of these knock-on effects by having the right economically positioned platform for the farmers to be able to use really the ideal practice that for them and their operation rather than the most cost effective one today.
Yeah. So, like for the weeding, is that like an implement or attachment that you guys designed specifically for that need, or is that something that's still down the road?
No, we didn't have to because essentially we designed a tractor. So a tractor is made to work with any existing implement, and we made sure that it worked with any Category 1 or Category 2 implement that we see existing on the back of tractors today, whether it's weeding, mowing, cultivating, plowing, any of that stuff. It all works with the tractor. We didn't want to tell farmers, hey, use our tractor, go throw everything out and go invest in an entirely new set of implements. So that was a really, really important one for us to make sure it fits in the ecosystem.
Okay, yeah, with the 3-point hitch and all the same connection points. All right. Yeah.
Exactly.
So, has anybody ever kind of put that together, like in a business case, to see what the savings is based on that?
Yeah, absolutely. Right now, just on the electrification side, we're saving like $12 an hour, and then on the automation, you know, if you're able to displace labor or reposition labor at higher value added activities, we're looking at, in California, $25 to $35 an hour. Um, in other parts of the country, it's a little bit less, but still, it's highly impactful. So, with all of that together, we're looking at payback periods at a high utilization operation, really within a year or two.
All right. So, what is your vision for the future for the sustainable farming, and where's Marna going from here?
We've had a great experience so far here in California in a lot of fruits and vegetables and permacrops, a lot of deployment into vineyards. But what we've learned is that the tractor does really well in other high utilization environments. So one of the areas that we're seeing the fastest growth is actually dairies. Dairies is a really interesting one because essentially the tractors are used like every day, multiple times a day, but in a fairly light duty application. And it really does the same thing over and over again, which is feed pushing. And this has a fantastic ROI because we're pulling the cost out of the operation. But if you can be very, very consistent in feed pushing, and you know this, you worked in dairies, the cattle eat more, they make more milk. So you see this great wedge in ROI on both sides of things. So this is just a fantastic market for us. And the U.S. has a lot of large dairies where the tractor is really interesting because it can actually go from corral to corral versus the other robotics that you see in dairies today, which can really only stay very much on like a flat surface like you'd see in a factory. They can't really go from corral to corral.
Yeah, when you get into the off-road side of things. Yeah, I did a couple of projects on, automated feeding and automated milking and things of that nature. Like I said, we've worked on a little bit of everything. Even worked on rice harvesting equipment, you name it. Um, so, I was looking through the specs on your website, and you're claiming 14 hours of runtime, and yeah, I can see, on a dairy farm, yeah, that's probably true. But the other thing you mentioned is, what was it? You have a 5.6 kilowatt exportable power. I wasn't sure. What does that mean?
It means that you can use the tractor like a mobile battery pack and power things out in the middle of the field, whether it's like a point solution, like a welder that, let's say you broke an implement and you need to get a welder out because you can't tow that thing in. Well, then you can plug it directly into a tractor. We've also seen a number of interesting things that farmers have done with this. For example, in harvest during the vineyard season, powering the weigh station rather than using a Jenny is something that every single operator really appreciates rather than sitting around sniffing diesel fumes and basically sitting there with your ears just ringing from the sound. So they really, really have liked using it for that application at that time. We see a number of different ways, though. One of the big ones is lighting. Lighting during harvest is another way that we can kind of use the exportable power without, running a generator or running an engine.
Yeah, that reminds me of a little situation we encountered here at Monroe a while back. I had a company that they had people coming from Asia, Europe, South America. There's like 16 of them here. And I pull into the office and all the lights are out. You have the emergency lights by the doors, but those only stay on for like 2 hours. And after that, this building, and we have no windows in our shop. So you can imagine how dark it is in here. Fortunately, we just bought our Ford Lightning. And if you go on Monroe Live, or I think it might even be on, you know, X or whatever, Twitter, but there's a Saved by Lightning was a little thing that was posted. So we literally did the same thing with the Lightning. It's got 220 in the back, like you said, for welding, but it's got a bunch of 110. We powered up a whole bank of lights in our bay. And then the girls up front are like, what are we going to do about coffee? Grab a coffee pot maker and say it on the tailgate. We're going to have a tailgate party today. But yeah, we ran that for 8 hours, and I think we only took out like 10% of the state of charge out of the battery pack. So yeah, it's definitely. I wasn't sure if you were doing something like adding additional kilowatts to the vehicle, like an extra pack or extended version, or is that something that you have in the plans though?
No, but what we have done is we've developed swappability and a swapping cart so that if farmers need to go 24/7, and this is a big thing in our market because there's no Tesla superchargers on farms, you have to be able to enable farmers to go 24/7. So we developed swappability into our pack and the swapping cart to go with it. One person can perform a swap on uneven ground, so in the field, in less than 7 minutes. And it's a 110 kilowatt hour battery pack, so it's not exactly small.
Yeah, that definitely. I'm thinking it's probably in the maybe 14, 1,500 pounds,
Might even be a little more. I'll
a little
tell
more.
engineers to slim it down, but yeah.
Yeah, steel housing, of course, but
It's also multiple layers because we have a very narrow vehicle. So in order to package that kind of energy, you kind of need to be able to use the vertical space a little bit.
so you have to lift the vehicle to pull the pack.
No, you
No,
don't. It
it's
comes
got to be
out the front.
close though, out the front.
It comes out the
Okay.
front. Yeah.
All right. So then just you have self-docking connectors in the backside, of course, I'm assuming.
Well, the way you essentially you just pull the cart right in front of the tractor. It engages underneath, so basically the lift grabs the battery pack with basically a ball hitch and a ball hitch feature to accept the ball hitch that we put directly into the battery pack. So basically, the big casting in the front engages directly with the ball hitch. You pull it out, shift it over, push it back in. We'll send you a video.
Yeah. Yeah. So like, you're not making any electrical connections. It's all like self-docking connections then for it, or
It is 100% a self-docking connection,
okay.
2 volts. That's it.
All right. Kind of like the what was it, the Model S?
Model S had the two different rapid mates. It was very similar to that. Yes.
Yeah. So are you heating or cooling the battery?
Because of our duty cycle, and this is one of the really, really interesting things about the agriculture application and the charging application that we have. If you have level 2 charging, the max charge rate that we're going to be able to get, is 19 kilowatt here in the U.S. and 22 in Europe. For us, that's less than 0.2 C. So we don't really have the thermal rise that you would see in an automotive application where you're doing DC fast charging. And it's actually even more gentle on the discharge side. So you're looking at mainly 0.1, zero point 0.2, even our max from a pulse standpoint. You don't see 10C discharge pulses in our application. Max is 0.5. So really, it's a very, very gentle duty cycle. And our testing shows that this actually really upholds the longevity so that we don't even need active cooling. I think that this is a big divergence from automotive, where active cooling has been shown to be absolutely necessary because of those duty cycles, but we really don't see it on our side.
All right. Yeah, that's not the first time I've seen that. Are you using LFP chemistry or
NMC chemistry.
NMC? Okay. All right. So what about if somebody in Canada bought your tractor?
Yeah, we've done the cold weather testing. We do see a little bit of degradation below negative 20 C down to negative 40 C. So there is some degraded performance at those temperatures, but we can still operate in many cases.
Yeah. So do you have to heat the battery up before you move it into operation then?
We stress that you have it plugged in before you use it in operation if it's that cold outside.
All right. So, I had a number of questions. So, like, my next one was talking about bus bars, but since you're using modules that you're purchasing, you probably are just connecting cable to from cell to cell or from module to module when you build up the pack.
Yeah, just those bus bars. So basically from module to module, just as you said.
Yeah, and it's probably all bolted connection.
Correct.
Yeah. So talk about that. So just think about, you said you designed around the battery pack. So can you maybe talk a little bit, like, how did you pull in the chassis side? What kind of transmission do you have, or how do you put the power to the wheels?
Yeah, so this is one of the unique things that we've done from a packaging standpoint that's really cool. Basically, we married an existing transaxle, so with an existing 9+3 transmission, and then we mount the primary motor in a transverse direction. So we use a spiral bevel to transfer the power over, and then basically the primary hydraulic pump is also driven off of that primary motor. And then the high voltage connection is in between all of that. So basically, we kind of stuffed it all together. And then for shifting, it's an automated manual. So basically, we designed an automated shifting mechanism that you can punch in with keys on the basically on the armrest. So and then we also bolted the primary hydraulic manifold on top of the transmission. So essentially, everything is connected together in this way for efficiency.
Okay, so on the transmission, so you just basically drive in the hydrostatic transmission design, or just
No hydrostatic, pure manual.
pure manual? Okay, and then, but you said the PTOs run off of that as well.
That's correct. So it's all run off of the primary the primary motor. And this makes sure that we can apply maximum power to the wheels, maximum power to the PTO, and maximum power to the hydraulics all at the same time. So there's no corner case where we can't do something because we're distributing power.
Okay, so with the hydraulics, is that for the steering and braking as well, or?
It is.
So it's very well integrated then. So it's basically, you got the hydraulics is going to be on, and then you probably have pressure regulation, and like you said, you had a manifold, and you're just going to divert it to where you need it then.
That's correct. It's always spooled up whenever it's in operation because of the need to have the hydraulics for implement function. It didn't make sense to go away from that for steering and braking and make it electric. It's much more cost effective to use that.
Okay, yeah, it sounds like you did a good job on it. We might be able to take a little bit of cost out of it for you.
I hope so.
So what about power distribution, from the battery? So you got 400 volts, that's running your main motor. What other power needs does a tractor have? I'm assuming a 12 volt for just your instrumentation, things of that nature.
We have two different screens for instrumentation. One is a control screen, and one is basically just a cluster. Then we have also the loads in the roof for perception, compute, connectivity, lighting, all of those things. Really, the way to think about power on the tractor is it's 90% PTO and implement function, 9% wheels, and 1% the roof, which has all of those systems.
Yeah. So are those like 12 volt then?
Yes,
Yeah. So you have a DC-DC charger, I'm assuming?
we do.
All right. How many contactors you have, like your positive, negative, and do you have a pre-charge, or are you using like bidirectional from the DC-DC to charge up your capacitors and for your inverter?
The way that our battery is constructed is there's two strings, so two different sets of contactors, and then essentially the way that it connects, we have a 12 volt battery operating on the 12 volt side, which is connected to the DC to DC converter, which also is functions as our onboard charger. So it's actually built into the same unit.
Okay. So, like, you don't have a pre-charge contactor circuit. You're using the onboard charger or DC-DC for that?
That's correct.
Okay. Yeah, I keep trying to get people to do that, and they always seem to want to fight that. Oh no, we have to have it. Um, so, just thinking about the autonomous side of it. Uh, since you worked at Tesla, are you just basically camera based, or do you have lidar, radar,
Well,
ultrasonic,
it's not
all?
the Tesla side that has driven us to vision only. It's the cost side. We want to make sure that the product is ag robust, and that means spinning lidars are probably not going to survive in the environment. And then radar technology is interesting for long distance and being able to detect objects, 100 meters down the road or something like that. But if we're going 2, 3 miles an hour in an autonomous operation, we only need, my arms. And I'm not a tall guy. My arms are more than enough stopping distance. So really, it's vision that we really need to train. It's the right sensor for the application.
The- So, do I have to worry about the neighbor's cat walking in front of the tractor?
You could, but we've trained it to recognize all sorts of objects, not just humans, but animals as well, and wait for human input just in case.
Uh, all right. Yeah, you answered a lot of what I was questions I had up front. So, I'm running out of steam here.
Sorry.
I mean, we kind of diverted to different topics and came back to it. So, yeah, okay, yeah. Eric's mentioned how many tractors do you have? I want to say I've seen just one, but there's three variants.
We have a number of different variants. So basically, there's one base tractor. It's around a 40 horsepower tractor. That we have a bucket loader variant. We've got a number of different wheel and tire options. We have a feed pushing implement that we've designed for one of those tractors. So there's 3, 4 different variants, and then we do have ambitions to make a larger one and a smaller one. They're a little bit down the road, though.
Okay. That I was going to be my next question. So you have one base tractor today, and you're looking at making a smaller one. You said.
Yeah, a smaller one really positioned at the hobby market or the emerging markets, and then a larger one to really handle row crops. I don't think we'll get into corn, wheat, and soy with electrification anytime soon, but we still talk about it.
Yeah, I've seen some of the bigger. I know, like John Deere, Caterpillar. They're all, they've all got something out there in that field. Are you trying to stay away from that size market or that applications and just kind of more of a niche where you're at, or?
Well, a couple of things. One, that is by volume a smaller market for vehicles. There just aren't as many of them. The second thing is what you really see in electrification in those markets is that the tractor just becomes too heavy and too expensive to be viable for the amount of power that you need to be able to basically deploy to operate implements at those sizes. So it really won't replace a tractor one for one. You could do a fleet of them, but that's really too far from what farmers do today. Whereas our vehicle fits in perfectly in a number of ag markets, and 90% of the ag equipment market is below 100 horsepower. So we're really playing in the right space for volume.
Yeah, I remember back on the farm, we had like 50 head of cattle and we had a Ford 8N, just a small tractor, but it might be a little bigger than what you have. But yeah, it's for pulling the hay wagons, the manure spreader, whatever else we needed it for. Mostly hay bales. Eric saying, ask about the app. Yeah, what was the app in there
Um, so
for
with a
connection to it, right?
Yeah, with a fully digital tractor that's connected all the time, we can essentially see and monitor what the tractor's doing if it's being manually driven, or we can control directly from the app. We can provide reports on utilization and operation efficiency. Really, all of the data, including the video data that the tractor picks up, is at the farmer's fingertips to answer the questions of what happens on a farm in the middle of the night while somebody's running an operation. Well, did you hit all the rows? Did you apply the spray at the appropriate rate? Being able to answer those questions today is basically hearsay today for farmers. And so if you really want traceability through the process, something we care a lot about in manufacturing, being able to actually perceive all of those things through a digital interface is something that only we can provide.
So, with all this software going on, do you guys do any like over-the-air updates or?
Yep, we are on a release cadence that's about once every 6 to 8 weeks now for continued platform improvements and continued capabilities that we're providing to our farmers all the time. So that's an important feature that we learned from Tesla, I would say.
Yeah. So, you actually get live feedback from the tractor and how it's being used, and you can
Absolutely.
monitor all that.
And we built a ticketing system directly into the tractor, so farmers can give us immediate feedback
Oh,
just
really?
by just by clicking on their smart screen and typing in whatever issue they're having.
Okay. And so, do you have somebody that monitors that 24/7 at your facility?
Sure do.
AI?
Not AI. No, we have people doing this, but that's a good question.
Yeah. All right. Yeah. Yeah, there's a lot. I mean, just from, we've taken apart, I don't know how many Teslas now, but I've seen some of the things that, like there's no motor temp sensors anymore. The initial Model 3 came out, it had temp sensor right on the stator coil. 2 years later, it was gone. It's like, okay, how'd they get away with that? But yeah, just through monitoring it and seeing the operating scenarios, you can insinuate or infer what the temperature should be based on current draws and a lot of other functionality. So, and I'm sure there's things like that in the back of your head that you're thinking about, that you're looking at, how do we implement this, or how do we eliminate that part so we can reduce the cost?
I think what we've done so far is we've gone all in on basically any functionality that a customer might want for any particular implement or operation. We've given to them for this first platform. What we're going to monitor is what doesn't get used and see if we can pull it back.
So, Mark, do you have any closing statements you'd like to provide us here?
No, I think if you're interested in trying out a Monarch tractor, we have salespeople all over the country, and we'll be happy to inform you when we're having an upcoming demo, so you can get eyes on our product, maybe on your farm. So happy to make that happen. Please come to monarchtractor.com, and we'll be able to route your inquiries very rapidly. So, again, thank you very much for having me on the show.
All right. Thank you, sir.